So here's a quick look at my mini project with the DAC with a speaker. You can hear the tune coming out from the speaker right here. And it's hooked up to the LM358 op amp and the DAC that we had made in Lab 2. And the volume adjustment there. So I can give you a quick rundown of the schematic, what's going on in the circuit, as well as the scope trace and looking at the volume adjustment with the potentiometer. So this started with, let me turn down the speaker, the original DAC that I'd made in Lab 2. And that was a 4-bit DAC for the TNC with simple resistor values of 2 times R for the pin outputs coming from the digital pins of the TNC with 1 R for the bridges. And on that circuit right here, I have 2 kilo ohm resistors coming off of each of those pins and 1 kilo ohm resistors acting as the bridges. So that's the simple DAC architecture, and that's capable of the 4-bit audio resolution that we have from this Arduino sketch that's showing the notes on the screen here. And the rest of the circuit beyond the DAC, so on this side, is actually the op amp as well as the bit that's connected to the speaker. So that was this mini project. I'm using this sort of schematic for the op amp, and I took a look at the data sheet for the LM358, and from that we can see that pin 1 is the output, pin 2 is the inverting input, pin 3 is the non-inverting input, pin 4 is ground, and the voltage in is pin 8. So going down those backwards, I'm actually running the op amp off of the 5-volt rail coming from the USB input for the TNC. We can see here that the lab description for the mini project said that the DAC has a limitation of it's not rail to rail, it'll only go to 1.5 volts of the positive rail. So the way that I'm actually getting 3.5 volts at the top is running it off of the 5-volt rail, so it doesn't have that limitation compared to if I was just running it off of the 3.3 volt for the TNC logic circuit. So after that, I just have pin 4 connected to ground, and then my voltage in, similar to the schematic, my voltage in is going into the positive input, and then the negative terminal of the op amp is the inverting circuit, and that's connected with a resistor to the output so that it functions as an inverting op amp. So in this, our gain would be the ratio of R2 to R1, and I'll talk about why I've wired this the way I have. So here you can see that the output of the DAC, which is right here, is going into pin 3, which is the positive terminal of the op amp. And then off of pin 2, I actually have the 2 megohm resistor right here that is connected to the terminal for the output. So it goes from the inverting negative terminal into the output. And then I just have a wire connecting the output into the potentiometer, which in this case is acting as a voltage divider. So one input is connected to the output from the op amp, one input is connected to ground, and then the wiper terminal is connected to this longer yellow wire that's acting as my signal output. And that I have connected to these capacitors. The mini project description suggested using a 100 microfarad capacitor, and the box was actually out, so I just put 2 47 microfarad capacitors in parallel for an equivalent capacitance in that ballpark. And then that is connected to the speaker that we have for the mini project. And the potentiometer is turned all the way down right now, but I can show adjusting the volume that you'll start hearing this. So no volume to slight volume to an increase. Down again. And up again. So that's the potentiometer working. You can do a quick, see that again. And that's the volume control working. and I can show the scope trace, which I'll show two scope traces actually, one with the speaker and one without the speaker, so we can look at the output from the op-amp and why I wired it the way that I did, as well as taking a look at what the scope trace looks like for the speaker output. So the first one, I'm going to take the speaker out. So right now the speaker is disconnected and I have the scope probe connected to the output of the potentiometer. So I'll bring this all the way up, and if we come take a look at the scope, you'll see that the two waves overlap. So we have the original signal, which is connected to the output of the DAC on channel 3, this one is, and then channel 1 is looking at the output from the DAC. And right now they're both approximately a 3.5 volt peak to peak, and then as I trim the potentiometer down, you'll see the output from the DAC going down and eventually reaches 0 volts with 0 amplitude. And so that's the full spectrum of the potentiometer. So we have full control of the output of the DAC, and that's a very, very clean adjustment that we can make. And now we'll put in the speaker and take a look at the scope probe. So now we have the speaker making sound. And the interesting phenomenon to note here is that this is what the trace now looks like from the input to the capacitors. Now, if I adjust the position of that probe to be where the speaker connection is, so the output of the capacitor is the negative side, we get this trace, which is interesting because that shows us that there's this voltage drop that's happening from the capacitor and the speaker. And then if I trim the potentiometer down, we get to 0 volts with 0 amplitude. And then when I bring it back up, we get this. Now, this looks like a case of not having enough gain, but I actually tested this out, and there's an interesting phenomenon that occurs, which is, right now this is at a gain of 1. Now, I could increase the gain by putting in a larger ratio of R2 to R1. Now, I already have a fairly high R2 with 2 megohms. If I take this 2 kilo ohm resistor and put it in from the inverting input to ground, so to create that R2, it'll create a very high gain because that 2 megohm to 2 kilo ohm resistance ratio is very high. Let me do that real quick. So I just did that, put in this 2 kilo ohm resistor right there, bridging the inverting input to ground. You might notice initially that the sound is a little bit muffled almost, and that's true, because what happened here is, if you look at the scope trace, it turned into a square wave. So we're now missing all of the higher frequency resolution. All we have is basically the low frequencies, which is why it sounds muffled. What's interesting to note here, you can see if I take out the speaker again, so as soon as I remove this, this is the, and let me adjust the probe to the input terminal, is that we have now created a square wave of very large amplitude that is actually maxing out. So with that high of a gain, we're basically running it beyond the positive rail of the op-amp, and so the gain on that signal is so large that we're just exceeding the maximum voltage that it can create. So we're losing a bunch of the fidelity, and just, we've basically created a very lossy signal. Which is why I had the gain of 1, because we're simply trying not to load down the DAC too much. So we're using the op-amp to provide power, and that's from the rails, so we're not losing that from the op-amp, from the DAC directly. And with this, we get that signal that we're looking for. And I can put in the speaker again, and this is the little speaker that we have connected to the DAC.